the keyboard wouldn't go down, so I had to figure that out. But, so what's going to happen here is I don't have enough room to write all of this out, but I am 18 years old. It is true that I can vote, and my political stance is U for undecided. We'll all be on the same line, and then we'll have a carriage return, so you'll end up here for the next line. Now, assignment statements, I talked about them a little bit. Okay, so in Java statements, the equal sign is an assign statement. What it means is it's giving a value to whatever the variable is. We read it as, and this is very important, so I'd like you to start using this language, becomes, gets, or is assigned to. Because equals is, it's just not great to use because we use Boolean information later when we say whether or not things are true and false, and so it gets confusing. So it also tells you that whatever that variable is now becoming something else, which is important. Like to understand that that variable name is getting a new value. Okay, so if I want to assign a value 2 to a variable named x, I can say x becomes 2, assign a variable false to assign a value of false to a variable named sad. I could say sad becomes, I should put a semicolon here, false. Assign a value of 7.5 to a variable named decimal. I could say decimal is assigned to 7.5. So you see I use 3 different ways that are okay to refer to assignment, and you can choose one of those ways and use that as well. All right, so there are 5 math operators. We all know addition, subtraction, multiplication, and division. These two, when we say unary, we mean positive and negative. So plus is addition and minus is also subtraction, but they also refer to positive as negative. So if we say like -5, we also use the same sign. Now, the only new one really that you don't know yet is called modulus. Okay? Modulus is the remainder of an integer or floating point division. So what does that mean? Well, it means if I say 10 modulus 3, I'm looking for what's left over. If 3 goes into 9 evenly with 1 left over, so 10 modulus 3 is 1. I'll write that so you get, it's like saying 10 over 3. What does that equal? Well, it equals 3, remainder 1. So modulus refers to the remainder. This one's a little tricky. I see it a lot. 2 modulus 4. Remember that 4 cannot go into 2 because it's too small. 2 is too small. So it would be like if you were to do the division, 0 with a remainder of 2. Anything that goes evenly, like 2 goes evenly into 16, the modulus is going to be 0. And it does also work with decimals. So you can see here, we used a decimal here with a modulus and a decimal here. It will actually calculate the decimal remainder for you as well. This is super, 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 super important. So if both the operands, so both of the things you're using in anything, are integers, in anything math related here, the result is an integer. If only one of them, that's why we say either. So if just one of them is a double, then you get a double. They like to trick you on the test with this type of thing. Okay, so I'll do a couple of these. You can see here 7.25 plus 3. Well, 7.25 is a decimal, so I'm going to say 10.25. Okay, here 7 modulus 4. I need a remainder, and so that answer is 3 because I have an int and an int. Now, here's where it gets tricky with integer division. Anytime anytime I have integer division, what happens is it truncates whatever is supposed to go after that. So 3 divided by 4 is usually 0.75. It does not round, though. What it does is it completely truncates everything after the decimal point. So 3 divided by 4 is actually 0. So in computer science, that answer would be 0. And you can try the rest of them if you'd like. Okay, so this one's a little confusing. If we say int a becomes this, we're actually going to get an error here. Because we cannot put a decimal into an integer. If you've read that extra reading that I had you read, remember that we have 2 cups, right? A big cup, and that's not a very good drawing of a cup. A big cup and a little cup. The little cup was ints, the big cups were doubles. So if I have an integer, I can actually pour an integer into a double. So I could say double x becomes 3. That's fine, even though I'm putting an int there, because the computer recognizes that this thing is just can be made into a double without having any precision, to call that a precision error. So it'll say, oh, it's fine. We can just dump that in there. We'll just make it 3.0. Does it like it better if you say 3.0? Yeah, but it'll take it. Now this right here that we tried to do, like put a decimal into an integer, no, that's not going to work, because if I try and pour this bigger cup into the integer, I should have actually made these different colors. Let's say I try and pour this cup here. What's going to happen? It's going to overflow. Okay? Now, I'm going to try one more of these. So, if this is declared a double after, what this does is, since these two are ints, it does whatever the integer operation is first, and then it turns it into a double. So, 7 modulus 4 is 3, and then I'll turn it into a double. So this is going to give me 3.0. I'm going to do the next 3 because these are closely related and can be kind of difficult. So remember, I said these two were integers, so it's going to give me integer division. So C is actually, and since this is an integer, it's actually going to just say C is 0. Okay. Now, even though this said double, these are still integers. So what it's going to do, it'll do the division, the integer division first, so it'll still be 0, but then it'll change it into a double, so it'll say 0.0. Here, this is what we like, where this is 3.0 divided by 4. This is, at least one of them is a double, so it turns it into a double, and so this is the only answer that's going to give me 0.75. I could also have changed this 4 to 4.0. They both could be doubles. Any one of those combinations would have been okay. But if, both of them are ints, then we'll do integer division. All right. So Java has a specific precedent, for math operators. It follows PEMDAS. So, if you just remember PEMDAS, you're pretty safe. The only thing you want to remember is that negative or positive comes first. Then multiplication, division, modulus. If you have more than one in it, it works from left to right. Okay. And then addition or subtraction. Just remember PEMDAS, parentheses, takes priority over anything else. So here's an example. So it's going to do, I'm looking in here and I see this and this. It'll do this one first. Sometimes 5 is 35. Then it will do this one. 35 modulus 8 is 3. And then it's going to work from left to right. So negative 9 plus 3 is negative 6. Minus 5 is negative 11. Okay. So assignment statements are used to assign a value to a variable. So I have int p becomes 7, int x becomes 4. But the value can change. So the next line of code, I'm not going to use my declaration because that only happens once at the beginning when I first declare. I can't make a p into a different variable because I said it's only going to hold ints. But I can reassign it to something else. So I can say P now becomes X plus 1. So now P has 5. Before it was 7, but now it's going to take 4, which is X plus 1, and it'll hold 5. Accumulation statements, I really like these because I'm lazy. And so what it does is it just tells you that your old value is going to be incremented or decremented or divided by or multiplied by or modulus by a specific number. Okay, so, and then this variable will now hold that new value. We write them like this. That's why I like the shorthand ones the best. You can write plus equals, minus equals, times equals, divided by equals, and modulus equals. So in this case, rate times equals 1.5 means you take rate, multiply it by 1.5, and it gets that new value. Sum plus equals 25, you take sum, you add 25 to it, and now sum holds that new number. Okay, you can even do it with variables here. A minus equals B. Okay, so what does it do? It takes A, it subtracts B from it, and then it holds that new value. The other thing I like to do is increment a variable. So we do this a lot, especially within loops when we do repeated behavior over and over and over again. And yeah, actually these ones are used in loops too, where we do repeated behavior over and over and over again. But this one's more common. So a lot of times we have to increment a variable. We need to go to the next one. So we could write count equals count plus 1, or count becomes count plus 1. I could say count plus equals 1 if I wanted to. So that's shorthand. But there's an even shorter way that you can do it. And that is by saying count plus plus. Okay, so if we want to increment something, we put A plus plus or plus plus A. If we want to decrement something, which means going down by 1, we're going to say A minus minus or minus minus A. Now, there is a catch though. Plus plus A and minus minus A, we're not going to use them on the test. And the reason is what they do is they increment and decrement at different times, okay? So we use this one. Why? Because B becomes A, and then A increments itself. So in this case, B becomes 4 first, and then 4 increments itself to 5. In this case, this happens before. So A becomes 5, and then B becomes A, which is now 5. I can look at this like this. Here's how the code does this. I'll start on this one. What happens? A becomes 5, and B becomes A, which is 5. Over here, B becomes 4 first, and then A increments itself to 5. So just note that difference. We're using the one that's highlighted, and the test will use that one as well. Okay, so type conversion, I believe this is the last thing we're going to discuss. Remember when we talked about, like, we need a double, we need a double, or we might need a, double to get us out of integer division. We can change something to something else by casting. What that does is we put the type that we want in parentheses before the variable, and if it can smoothly, it will convert that. So what happens is, like, if you cast something, a double specifically, to an int, what that does is it truncates it, I believe. When you go to double, we less often use that, I believe. It might result in I'd have to check that out. It may result in a precision error, but since you're forcing it, it might be okay with that. Because you're telling the computer, I'm forcing this type to happen. We more often go from an int to a double, and the reason for that is so that we can avoid integer division. Okay, so I'm going to do the second one because that's the most often that we'll see it. So we want to cast to revise the following operation so that results in a decimal value. I can either say double 3 divided by 4 or 3 divided by double 4. So what that does is this forces this to become 3.0, and then this tells the computer to force this to become 4.0. Now, we can also do it between integer and chars because, like I said, they're interchangeable. Okay, so you can use your ASCII chart and look that up. I'm not certain if the computer will, like I said, allow you to go from a double to an int because it may give you a precision error. You can definitely try it out on the computer, though, and see what happens. And that is all of Unit 1. It was a long one, but hopefully you can get the hang of it easily, and then we can move to something that's a little bit more exciting.